All right, so once again, good day, learners. So today we will now jump to multiple linear regression using similar predictors in your research. So, but today I will be only using data set for ecological research. So, as previously I had tutorial on linear regression explains. So in this, I was only working on two variables, but now here for multiple we'll be using variables. So without further ado, let's try to jump into the R code. So again, um, I'll try to make a new file R script just to make sure that it is clear in terms of the modeling. So with that, we need some kind of a library and tidyverse again. So again, if you don't have this package, you just upload some packages, install, and just type in tidyverse like this, tidyverse, and there, just click it and install, and let's say car there and install. But I'm not gonna do that because it's already pre-installed in my R Studio. So for that, let's try to create a simple data set. So again, in my previous tutorial, I was only working on DBH and species and DBH and height because it was linear regression and we need two numerical uh, variables. But in this case, because we will be using multiple regression, so we can use either uh, the species, elevation, and which again, multiple regression requires more than two variables. It could be the location, it could be environmental factors such as temperature, rainfall, and any other variable, let's say climate, vapor pressure, or whatever that is that you want to include in your model. But again, the more variables you have in your model, the more complex will be the model. So I think my suggestion is to work on simple models and just explain in your methodology that you use simple model because you're only you're just looking at how one variable is affecting another variable. All right, so let's try to create a simple data set in here. So again, this is how you select to create a data set. So data set, and I'm creating a table. So again, DBH, 60 observations, mean 30, standard deviation 6, elevation I would say 60, 400, mean 400, and standard deviation is 60. So this is higher because we wanted to look at the patterns of elevation. So I would expect elevation from 400 to 800 meters above sea level. And species, in this case, we only have two, Sharia and Meteorcarpus, and also 60 observations. So let's run this data. Mm, So just run all of and then data. There you go. We have now the data, 60 observations, three variables. TPH, elevation, species. So you can click that. We have the Tercarpus and Sharia elevation 215. Maximum is 574 inches. It's quite uh higher elevation range. And DBH we have minimum is 18, maximum is 43, which is I think it's already like a good data for this work for this simple tutorial. So for that, let's try to create a response variable. So it's a response variable. Why do we need a response variable? So again, there is so-called response variable and explanatory variables, or you can call it dependent and independent independent variables. So I sorry, I think that's pretty self-explanatory now, like independent variables. So let's say you're looking at how sleep is affecting your score exams for tomorrow. So it's like now you can say if I sleep better, if I sleep longer, can I get a score? So you can say the dependent there is dependent and independent variable in there. Like you can say, yeah, sleep would affect scores, but it depends if you studied, right? So it has nothing to do with how much you sleep, but it also being affected by other factors. That's why you can do multiple regression because you want to include all other variables that are somehow directly or indirectly affecting your response variable. All right, so let's just stick to this to be able to understand what is our response variable. So create a response variable height. So we will try to do that. So just run it. Now our variables is height. So maybe we wanted to look at if a species is affecting height and elevation is with the height and maybe this. So let's have a simple regression modeling. All right. So now let's try to run this simple model. Fit multiple regression. Okay. So the idea of regression multiple is you're using a lot of variables. In this case, we wanted to protect height. So we'll be using linear modeling and our um I will look at explanatory variables here is dbh elevation species. So see, we are now protecting the height in as a response variable based on dbh, based on elevation, and based on species. In that case, we have actually three so-called independent variable. So our dependent variables depend. So this is dependent on this aspect. So how species is responds to height, how elevation responds to height, and how deviation is responds to height. So the same with this system. We can call it response variable, and these are explanatory variables or independent variables. So let's just run this. All right. So now we have the model, and let's say summary of model. Now we can see the summary of a model. This is interesting. So again, do not be complicated with all these values in here, but just look at the estimate. So the intercept, the DBH 0.6 and elevation C, we have a negative relationship. DBH doesn't really like, you cannot expect that the higher elevation, the higher the height. So in that case, we can expect that the lower elevation has higher height. So that would be my assumption now because it has a negative relationship. Okay. But then if you try to look at the p-value, so all are highly significant. So you have 3 asterisk, 2 asterisk. So but I wanna our adjusted value is 0.73, which is also higher. So I would say our model is nice. But then let's try to look at other like check multicollinearity. So there's so-called BIFs. What is a BIF? BIF stands for variance efficient factor. So this is what happens when your um, variables that you use are highly correlated. So, for example, DBH is highly correlated with species. So in that case, you cannot really use both of this. But then because this is not numeric, this is numeric, so you can use again before you run your model, you have to check your independent variables if they are highly correlated. So let's just check the IP BF model. So BF model is so far is good. We have elevation 1, elevation species 1, so which is so far it's good. So based on the BI factor, possible problem, negative, uh, higher than 5, VIFS should be greater than 10, serious problems. So far, we don't have problem with this. Our model is okay. Our VIF is 1, so I would say there is no problem at all, which is good. I like this. Now let's try to look at the library effects. I just want to put in here so that it's easy for us to really work on it. And the plot that we wanted to. So I'm just gonna run this. There's no package effects. So this is what happens. So now let's try to search effects. So it should be with S effects and install, and you wait until it will be loaded. So you can see there, you can see this stop. So when it is gone, it means that the package is already loaded. But still working on. I don't know what's happening. So we have to wait a little bit. So see, there's a notification that's actually loaded. So just run that again and just plot all effects model. So which is, wow, this is interesting. I want to see this. So let's wow. So this is now your output, and basically you can already like copy that output to your research. Let's try to look at height, and height. So let's first is look at maybe I wanted to all of this. Okay, just stick to that. So let's say I'm gonna start with DBH effect plot. So see the DBH, it says here the higher the DBH, the higher the height, which is good. Like I would say linear relationship, uh positive linear relationship. Then if you try to look at as well for the elevation, so it is negative. So that means that when the elevation increases, I don't know if you understand this, but see, elevation is 200 to 600. So it means that the higher the elevation, the trees that it tends to be shorter. So let's say if your elevation is at 200, so you expect the trees is at 28, right? And this is meters. And here for elevation 600, you expect that the height is 20 tall. So it means that it's a neg, but it doesn't mean that it's not a good thing, but it will just give you an idea like, oh, so trees literally grow taller at lower elevation. But then again, this is your data, so you should not generalize this with other studies. But because we are only using a, a created data set, so but again, this is how you interpret it. So another plot is the species effect. So because we only have species, so you can see, oh, the paragraphs is here, Shoria is here. So you can see Shoria is more in terms of height. So Shoria is taller, I would say taller compared to the Pterocarpus. You see the height for the Pterocarpus is only 23 meters and Shoria is around 27 meters. So by looking at this figure, you can already like, oh, okay, that's interesting. And if you like this figure, you actually just copy like that. Let me just do it one last time. Let's just try this. I don't like this, but it's just let me just try to click one. So if it doesn't fit to you, I don't like this one. So you can probably just I'll save this video. Portrait landscape. Let's try landscape if it will work. So here, see if there is something tutorial. So there's the R plot. And there you go. So I don't like it. It's very messy figure. So actually it's important for you to really like click. So that's why I prefer to have a bigger screen. I have actually an extended monitor. So to be able to really like, look at my figures bigger. Okay, let's see if it will this. Still very small. But yeah, usually if you have a bigger laptop, you can directly, you know, go like this. So you can also like it. I'll try to just copy and put it here. Let's say maybe it will work. Maybe it will not. So and brush it out. Okay. But again, it should work because right now can see the image. What about this? Maybe it can work. All files. Yeah, probably. So let's try to save that. Not working. So let's say copy image. It just so it's not working, but I believe that if you try to save it as like this and just make sure that you have use space Excel ratio. Yeah. So, just try to do like this. So depending on if it's already visible or not for you. I have a very small screen, so that's the problem. I have this small laptop. Anyway, so I think we already understand that look at the results. So again, this is pretty interesting results, and I think I can have already like get the idea like, oh, okay, the higher the height, and here the elevation is there's no such thing as it's like when you look at the result, you say, oh, it's negative, but then it's kind of not. We just go back to the model here. So you see, it's a negative elevation. It doesn't mean that it's a bad thing. It's just we're just trying to look at what happens in the field. So it's highly significant. It means that it's negative relationship. Again, the lower the elevation, the higher the trees. That's what it means. So do not be confused with the information that your results is showing here. So again, it's important for you to look at your data. So there's another thing, model selection stepwise. So this is really good. This is this is where it can help you out, like because like I don't know if let's say imagine if you have 10 variables and you wanna use temperature, you wanna use precipitation, rainfall, whatever that and you have to also include location. Let's say location is in Balearian Island, later or another. So it's the more variables you have, like you have more variables you want to put into your model, the more complicated it is your model, and the more it will be hard to interpret. So that is why it is important for I'm really suggesting or recommending to use simple modeling. So this is another thing, simple step model. So let's run this. So you can see step. So it's like modeling like this will help you decide, it's the biggest decision of your life. Yeah, let's say start with AIC 126. That's interesting. These are your variables. So it will just simply show you your variable elevation, species, deviation. In that case, like, okay. So it says here start with EIC 126 in that case. Again, I've mentioned that the lower the EIC, the best is the model, right? So in that case, I would say, mhm. So maybe I will try to elevation this one. So it's like, okay. So it says 156, elevation is 133, distribution is 156, and deviation is 179. So it's like, all right. So maybe I will try to use only elevation or species, or you can actually just, run a separate model in each. So you can also do that. So let's say I'm gonna do like this for you to like you can really just play with the data and do modeling. So let's say one. Our model one is this. So let me just copy this data because I don't want to write it again. Uh-huh. So LN model, the one, but I will stick to image. This is simple model. Oh no, because this is just say because this is multiple modeling, so multiple regression. So let's stick to that. And I want to use only two variables. So let's say, but I will try to create another model. Model two, but this time is DBH and species. You can always play with your data and like, make sure that you know what you're doing. So it's important for you to know exactly why you use it, why you use this model, why this model, and stuff like that. So DBH, I'm gonna stick to a species. I don't know, like species plus elevation. So and you can, so on and so on. You can just, like based on this, you can say, okay, I'm gonna use elevation and species. So use this model, or you can use this model here, and so on and so on. So let's say you just let's just run this model level 1 to 3. All right, so we have loaded our model, and now the interesting part is I want to check this based on EIC. Let's say summary. Let's see. ANOVA. So there's another thing, ANOVA, and model 1, model 2, model 3. So see, what you can see there is just the EIC another, that's the variance table. So here, okay, we have a lower RSS, and model 3 is higher, high RSS. So okay, maybe I could do some, um, I can run it one by one. So model 1, let's say, yeah, there's this p-value that we can actually do like this, and can see it model 1. Okay, 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 okay. So that's interesting. So that's how you do it. How do you? So again, remove sensitive breakers, fix symbol model. Simple as that. So in that case, based on this step model, you can just choose. I mean, this is good when you have like 10 variables, but you have 3, so I think it's okay. But usually can make again my definition use simple models. So that was, let's try to have interactions. Interaction is um another multiple modeling, regression modeling. So in this case, let's say the height, DBH and species, so maybe species and DBH and elevations are not class. So that's called interaction model. So let's run this model interaction and model summary. All right, so now we use summary. So the species area, hmm, there's not significant, still, but the DBH and species no significance. You can see the p-value is quite, so that makes sense to me, I would say. So again, it depends on how you interpret it. So look for interaction. So DBH species. So again, this is very important for you to look at it. So here is the results. Here is the DBH. It's not significant. It's 0.07. That's the estimate. And yeah, this is just like simple. I want to try the model interaction. So this is how model interaction. So let's just try to model interaction. Two. It's interesting. So again, I wanna check this. Looks good, but the points are like are some arrogant outliers. So it's straightforward that there are some things that are, and it's this one. So p-value is 0.05, which is, so I would say it's not normally distributed because p-value is 0.02, which is lower than 0.05. So makes sense. So yeah, I think that's it. And then with all the information you can only write, you can produce the figures, upload or download the figure that you wanted to show. It really depends. Again, it's your decision what kind of story that you want to tell your readers. So, and also it's your decision, like which results that you want to show, the ANOVA table, the figure, and the summary of your DBH and stuff like that. So it is your job to decide what kind of figure table that you wanted to present to your Twitter. And then you can already, copy all your results from here. Let's say I wanted this results and kind of it's gonna be kind of so figure blah 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 and then figure one relationship of this and that. And that's it. And then you can interpret and write the story and that's it. And then you are good to go. So yeah, I think that's all for this multiple regression. So again, I am Dr. Rafi Drago, and if you have questions, clarifications, any other comments, you can reach me out at my email address, rodrigo@gmail.com, and my work email, rafi.rodrigo at ipso.edu.ph. Again, if you are interested to know more about this, I have some ebooks already. So mastering our step-by-step guide for researchers. So I have put everything, imagine I put every details in one uh ebook. So the content is this is like how to install R, how to use R directory for the data and data type, data structure, also functions, missing values, script statistics, data visualizations, and hypothesis, regression, advanced tools, writing and reporting results. So this is really good, I would say, if you're interested to dig deeper about data analytics. And once you've done this and you're ready to, you're already able to produce all the figures and tables that you need for your publication. Now you can also read my second ebook, which is Scientific Writing Simplified, a practical guide to publishing. So this is a very ambitious ebook as I wrote it here on chapter 3, writing your manuscript in 7 days. This is possible as long as your story is there already, your data is clean, and your data is and your figures already ready, and you just write the story. So here are the results. So this is interesting here. I want you to really read this one. So day one is results. Like how on earth do you start with your results? Again, this is possible when you have everything in order. You have already produced your figures, the story, what kind of story you want to tell your record, and what information you wanted to share to your audience. So again, data is information. So if you give us the right data, I mean, if you have the right data, I'm pretty sure that you're giving us the right information. So I think that's all for today, and see you for my next video tutorial. So have a great day.